Most of the assets of a power system live inside electrical substations. But if you're not familiar with the equipment, it kind of all looks the same, and it's difficult to make any sense of it. So let's take a look inside a substation and we'll learn about the different assets, their main duties, and how they operate. First of all, let's look at the substation from a very high level. And this diagram shows a single phase equivalent. Of course, a real substation will have 3 phases and it will likely have several feeders. So what you see here is replicated many times over inside a substation. Now, the first asset we'll look at is the voltage transformer or current transformer. Normally a substation has both. VTs and CTs have the job of measuring voltage and current in the substation. It then passes this information either directly to a relay to make the decision on whether a fault condition is present, or it goes into the communication infrastructure of the substation and then passed on to the control room. Modern VTs and CTs have merging units. These convert the measured voltage and current into a digital form that can then be passed into IEC 61850, which is a new communication protocol for handling digital information inside a substation. Old-fashioned CTs and VTs can send the recorded signal straight to a relay. The next one we'll look at is called the disconnector. So the disconnector is a very simple asset in construction. It's made up of a swinging arm. So this is just really a mechanical switch. Now, disconnectors are cheap, they are reliable, but they're not able to break load current or fault current. So that's one of the big weaknesses of a disconnector. In fact, if you try to break load current or fault current, you just get a giant arc. So it's a very specialist job actually to break fault current and load current. But disconnectors do play an important role inside the substation because they allow other assets, most importantly the circuit breaker, to be isolated. And it's reassuring if you're working or maintaining a circuit breaker, it's reassuring that you have that physical separation between you and the rest of the circuit. That's a disconnector. Now we move on to the circuit breaker. So as I mentioned before, the circuit breaker has the important and difficult job of breaking load current and fault current. And this is really difficult actually. So circuit breakers tend to be more complex in construction and therefore more expensive, but they play such a crucial role in the protection system of the substation. So most circuit breakers have some kind of mechanism to physically pull the two connections apart and then extinguish the arc. So examples of this are air blast circuit breakers and SF6 based circuit breakers. So that's the circuit breaker. They're very expensive, but really important inside a substation. Now, the most expensive and largest asset inside the substation is the transformer. So the transformers really are playing a very important role inside a substation because they step up and step down the voltage. Now, one of the most striking features of the transformer is the giant radiator that's normally bolted on the side of the transformer. Now, the purpose of this radiator is to help with the cooling of the transformer because, transformers transfer vast amounts of energy and they do run hot. So oil is used as the coolant, but the radiator on the side is an additional measure to help cool down the transformer. And typically oil will flow through the radiator and you'll have heat exchange. You also sometimes have fans underneath the radiator to help with the cooling, just as you would in a laptop actually. Now the main chamber houses the windings, and of course this is where the electrical role of the transformer is carried out, the stepping up and the stepping down. And we also have a noticeable feature is an oil containment measure. So transformers contain lots of oil, and if they leak, there has to be a way to contain that oil. So normally an oil containment measure. Sometimes these are called bunds. They're used to contain any leak of oil. Now, on the protection of the transformer, when the transformer fails, normally you get a reaction in the oil which causes the level of the oil to fall. So a Buchholz relay is a very cheap and effective way to monitor this and to detect a transformer failure. So you'll always see a Buchholz relay on a transformer. It's just a way to detect failure in a transformer in an automated way. We also have in a substation a building called the relay house. And as the name suggests, this is home to the relays. Of course, the job of the relay is to monitor the voltage and current and make a decision on whether there's a fault. If there is a fault, it will send the signal to the circuit breaker to trip. So the relay is an automated way to do this. We also have the battery. So the battery in the substation is a way to power the equipment if you get complete power outage. So really important. The battery is so important in a substation. And we can group together the VT and CT, the disconnectors, and the circuit breaker and call these the protection system of the substation. And they perform a really important job in the substation because they actually protect the grid from faults and automatically respond if there is a fault. So let's group these together and call them the protection system. Now, there's also one other type of asset which is important. This is called the surge arrestor. And the job of the surge arrestor is to protect the transformer and other parts of the substation against high frequency surges such as lightning strikes and switching surges. The conventional protection system isn't fast enough to protect against lightning strikes and switching surges. So all these assets together are called the protection system. So all of these assets work together to form the substation. So we've gone through all of the main assets now. There is one other important element of the substation called the bus bars. Now, the bus bars are the way that all of these assets are connected together. So you can think of bus bars as just a low impedance piece of metal which connects assets together within the substation. Obviously, these bus bars are very high above ground, so they're at a safe level, but they're also very important. Another important aspect of the substation is the earthing grid. So underneath the substation, you have a grid, a metallic grid, and that helps maintain safe step and touch voltages within the substation to protect personnel from dangerous voltages and to also provide a low impedance path to ground if there's a fault.